Okay, let's unpack this. Um, what if you could essentially give your technology superpowers?
Superpowers.
Yeah, like the ability to tell you exactly what's happening inside, even when it's, hidden from view. Today, we're really digging into the world of observability within SRE and DevOps. We're pulling insights from a really great interview Q&A
hmm
and our mission, basically to cut through the jargon, get you right to the core understanding of how your systems can, well, reveal their secrets.
And it's fascinating, isn't it, how vital these concepts have become? I mean, think about the complexity now.
Oh, absolutely.
Ensuring reliability, performance, it's critical in today's digital world. Doesn't matter if you're a dev, ops, or honestly just someone who uses a lot of apps. Understanding this stuff is key.
Totally agree. So let's start at the beginning then.
Right.
What exactly is observability? Especially in the context of, say, site reliability engineering SRE.
Right. Well, at its core, observability is the ability to infer a system's internal state just from its output.
Infer its state from outputs.
Okay. Yeah, think of it like being a really good mechanic. You can diagnose a complex machine, maybe a high-performance race car, right?
Right.
Just by listening to its hums, feeling the vibrations, checking the exhaust, you're figuring out what's going on inside.
Mm-hmm.
Even deep in the engine, based only on what you can perceive from the outside, you don't necessarily have to open the hood immediately to know if something's wrong.
I like that. Diagnosing the car without always popping the hood.
Yeah.
Makes a lot of sense. So how do we actually build that capability into our systems?
Right.
Like practically.
Well, the source we looked at breaks it down nicely. It talks about the three pillars of observability.
Oh, the three pillars. Okay.
That's right. These are basically the fundamental types of data that give us those insights we need, that race car diagnostics level of understanding.
Right.
And they are metrics, logs, and traces.
Metrics, logs, and traces. Okay. Let's start with metrics. When I think system health, I think numbers, performance stats. It's like taking the system's pulse.
Exactly. That's a good way to put it.
So how do we actually capture these vital signs? And what do we do with them?
So metrics are basically numerical measurements about your system collected over time. You have tools, like Prometheus is a common one,
Right.
and it acts like a digital health inspector. It scripts targets at intervals is the term.
Scrapes targets,
Right.
meaning it asks the services for data.
Yeah, essentially. It knocks on the door of your services periodically and collects specific measurements, like how many requests came in, how long did they take, how much CPU is being used.
Gotcha.
And then it stores this time series data. So you get a history, you see trends, you spot anomalies, you understand performance over time.
Okay, and the source mentioned SLIs, service level indicators, as a key use for these metrics. We hear about SLIs a lot.
Mm-hmm. They're crucial.
But the source makes a good point, right? It's not just having the SLI, it's making sure it actually reflects the user experience.
Precisely. And SLI is, well, it's a specific metric chosen to measure reliability or performance. Think 99.9% uptime or average response time under 200 milliseconds.
Okay.
But the insight is it shouldn't just be some internal technical number. It needs to be a proxy for what the user feels. If your response time SLI starts creeping up,
Yeah.
that's not just a tech problem. That's potentially frustrated users leaving your site. So it helps you know if you're hitting your user-facing goals.
Right. Makes perfect sense. So, okay, metrics give us the numbers, the pulse. They tell us what's happening. Maybe that something's slow or error rates are up.
Mm-hmm.
But what happens when the numbers say something's wrong, but not why? That's where logs come in, right? We always hear, check the logs.
Exactly. Logs are the second pillar. They're discrete time-stamped events, like a detailed diary entry for your system at a specific moment.
The diary.
So for troubleshooting, yeah, you search logs for errors, patterns, context. If something crashed, the log might have the exact error message the function it was in.
The smoking gun.
Sometimes, yeah. But, in today's distributed systems, it's rarely just one log file.
Oh, true. Yeah.
The real insight here is about correlating information across potentially huge volumes of logs from many services. You're not just finding one error, you're piecing together a narrative. That's where things like structured logging and good log aggregation tools become absolutely vital. They turn noise into signal.
Gotcha. Structured logging and aggregation makes sense for dealing with the scale. Okay, so metrics are the pulse, logs are the diary, then traces, the third pillar. These seem especially useful for those really complex distributed systems, right?
Oh, absolutely essential.
How does distributed tracing help with debugging those sprawling architectures?
So distributed tracing, it basically tracks requests across services, and crucially, it shows latency and errors along that path.
Tracks the whole journey.
The whole journey. Think about a modern app, maybe an e-commerce site. You click buy now. That single click might trigger actions across, I don't know, dozens of little microservices behind the scenes.
Right. Inventory, payment, shipping.
Exactly. Without tracing, if something's slow or breaks, finding which of those dozens of services is the culprit is incredibly hard, like finding a needle in a haystack.
Yeah, I can imagine.
Tracing gives you that map. It shows the entire path of that single buy now request, from the first service to the last, highlighting where the delays are, where the errors occurred. It gives you the full picture for one transaction.
That sounds incredibly powerful.
It really is. I remember this one time, right? We had this really weird bug report, users complaining about slow loads, but it was intermittent. Totally random, it seemed.
Yeah, the worst kind.
Tell me about it.
It wasn't until we implemented distributed tracing that we finally saw it. There was this one specific database call, like 15 services deep in the chain,
Wow.
that was randomly taking an extra 3 seconds sometimes. Without tracing, we could have been looking in the wrong place for weeks. It fundamentally changes how you debug complex stuff. That's a great example. Really highlights why it's needed.
Okay.
Okay, so we've got these 3 pillars: metrics, logs, traces. Different data types, different perspectives. How do we pull it all together? And importantly, how do we get alerted when something needs our attention without just getting flooded with noise?
Right. Good question. That's where visualization and alerting come in. You need tools. Grafana is a popular example.
Heard of it?
Yeah, it lets you visualize observability data. It takes all that raw stuff, the numbers from metrics, the text from logs, the paths from traces, and turns it into dashboards, charts, graphs, you name it.
So you can see it all in one place.
Exactly. And the real power isn't just seeing each pillar separately, but combining them. You might see an error rate spike in your metrics, but then you can correlate that time frame with specific error messages in your logs, and then use a trace linked to those errors to pinpoint the exact service and operation that failed. It paints the whole picture.
That makes sense,
Yeah.
connecting the dots.
Precisely. And then alerting. Its job is to notify teams of issues needing attention. You set thresholds on your key metrics or log patterns, and when those are breached, the system tells the right people. Because like you said, data without action isn't very useful, is it?
Not at all. Okay, one last thing the source touched on. These different ways to monitor from the outside, like a user, versus from the inside, looking at the system's internals. Black box versus white box monitoring. Can you break that down?
Sure. So black box monitoring tests a system from the outside, simulating the user experience.
Like, can I log in? Does the search work?
Exactly. It's like checking your car. Does it start? Do the headlights turn on? You're interacting with it externally. You don't care how it starts, just that it starts. It's vital because it tells you what the user is actually experiencing.
Right. If the user can't use it, it's broken, regardless of internal stats.
Correct. Then white box monitoring differs by monitoring internal system metrics and health. This is like checking the car's engine oil, the tire pressure, the battery charge.
The internal gauges and diagnostics?
Yeah. You're looking inside the system. CPU load, memory usage, queue depths, database connection pool size. Things the user doesn't see directly, but which indicate the health and potential future problems.
So I need both.
Absolutely. They really complement each other. Black box tells you if it's broken for the user right now. White box often tells you why it broke, or maybe even predicts it's about to break. Relying only on one gives you an incomplete, sometimes misleading picture.
Got it. Black box for the what, white box for the why, and what might happen. Makes sense.
Right.
Okay, so in this deep dive, we've really unpacked observability. It's that ability to understand the system's internal state from the outside.
Mm-hmm.
We broke down those 3 key pillars: metrics, logs, and traces, and saw how they work together for debugging and just understanding system health.
Yeah, they're the foundation.
And we looked at the different ways to monitor black box, the user view, and white box, the internal view.
Both critical perspectives. And, thinking bigger for a second, connecting this all together. Understanding observability, it isn't just about fixing things when they break, is it? It's really about building systems that are transparent and resilient from the start.
That's a great point. Proactive, not just reactive.
Exactly. So maybe the question to ponder is, how can mastering these insights actually transform how you design and interact with any complex system you work with or even build? How do you ensure it's not just, functional, but truly robust, adaptable, and, well, reliable?